Hello friends. Today we are going to tell you about the well-known company, SONY Cooperation's new space project, SOLISS. SONY Cooperation is one of the most famous companies in the world. SONY Cooperation's success in various sectors such as mobile phones, camera, televisions, laptop computers and communication sensors. These consumer electronics made SONY name a unique global brand. SONY Computer Science Laboratories launched a project in 2015 to establish a transmitting high-definition (HD) image data via Ethernet to the International Space Station. Today we are discussing the performance targets and future goals that the joint project has achieved by April 2020. The Japan Aerospace Exploration Agency JAXA, the National Institute of Information and Communications Technology NICT, and SONY Computer Science Laboratories SONY CSL announced that they were successful in establishing a bidirectional laser communication link between small optical link for International Space Station. It calls SOLISS. It was installed in the exposed facility of the Japanese Experiment Module (KIVO) of the International Space Station and the Optical Ground Station for Satellite Communications of NICT, and in transmitting high-definition (HD) image data via Ethernet. This marks the first time in the world that bidirectional symmetric Ethernet links have been established by using laser communication devices designed for small satellites. The SOLISS system was installed on the KIVO's exposed facility on the ISS in September 2019. Since then, in order to establish a bidirectional laser communication link between the onboard system and the optical ground station, communication tests have been conducted about once a week, weather permitting, while making adjustments to various parameters. As a result, on October 25 in 2019, an optical downlink of fine-pointing control from SOLISS to the optical ground station was successfully established. On March 5 in 2020, bidirectional laser communication link with the optical ground station, using a laser beam, with a wavelength of 1.5 micrometers was successfully established. Furthermore, on March 11, HD images were successfully received at the optical ground station from SOLISS via 100 megabits per second Ethernet. JAXA and SONY Corporation have been conducting joint research since 2016 with the aim of establishing real-time mass data communication system for future inter-satellite communications, and communications with ground stations under the Request for Proposal Joint Study Framework of the JAXA Space Exploration Innovation Hub Center. Starting in 2017, SONY CSL undertook the task of basic research and JAXA and SONY CSL jointly developed SOLISS for the purpose of realizing mass data communication over long distances. The Optical Communication Unit employs the optical disc technology that SONY Corporation has cultivated over many years. JAXA sent the SOLISS system to the ISS via the H-2 Transfer Vehicle HTV-8, KOUNOTORI-8, in September 2019 using the KIVO's Paid Utilization Program. The system was attached to the EVA Replaceable Small Exposed Experiment Platform (i-SEEP) hardware adapter installed on the KIVO's exposed facility. NICT and SONY CSL have been jointly conducting research since 2018 for the purpose of demonstrating bidirectional communication between SOLISS and the optical ground station. NICT provided the knowledge based on the development technology of the optical communication terminal for the on-satellite system, and they jointly carried out the measurements and experiments necessary for SOLISS in-orbit demonstration. The success of this bidirectional laser communication experiment is the culmination of efforts from each parties, where SONY CSL conducted communication testing while NICT provided technical support related to experimental operation and JAXA supported the in-orbit operation of the SOLISS system on i-SEEP. The benefit of laser communication compared to radio wave is the physical ability to scale its bandwidth. The success in bidirectional laser communication demonstration using long-established optical disc technology, and the Ethernet standard will likely create a pathway to ultra-high-speed data communication, and real-time mass data communication for cross-links between satellites and between a satellite and ground stations in the future. JAXA, NICT and SONY CSL will proceed in carrying out detailed analysis and evaluation of the experimental results. Furthermore, experimental operation aimed at improving communication stability using SOLISS is planned to continue until early June 2020. Hiroaki Kitano, president of SONY CSL, remarked. The optical disc technology that SONY has cultivated over the decades controls light at a very short distance of 1 mm or less, but this time it has been proved that this technology can be applied even in long distance, between space and ground. This technology is not only high precision and low power consumption, but also provides new opportunities due to its small size and mass production technologies. We regard the success of this experiment as an important milestone for future development and commercialization. The research started in 2015 as a part of the JAXA Space Exploration Innovation Hub Center program. With the respective joint research projects with JAXA and NICT, we were able to achieve the successful results this time in a short period of time by using their existing space programs, platforms and equipments that allowed us to implement agile processes in the development of SOLISS. If you are interested in latest technical information like this, subscribe our YouTube channel. And don't forget to share this video with your friends. Put all your suggestions on this video in the comments section below. Have a good day.